Welcome to Campus Voice Time Beyond the Lab. I'm your host Ruth Jepkori, and today we are breaking down science and innovation. With me in the studio is Lewis Minda, a final year engineering student here at the Technical University of Kenya. Lewis, welcome.
Thank you for having me.
Let's dive in. First off, tell us a bit about yourself, your course, and academic interests.
I'm a final year electrical engineering student at Technical University of Kenya. And about myself, aside from school, I'm also part of an NGO out of the street community. And now my course and my academic interest, I chose specifically electrical engineering, majorly because it's embedded across almost all facets of engineering. And within electrical engineering, I did not choose electrical engineering to climb on top of posts. In electrical engineering, I chose it, and what interests me in the field is telecommunications part of electrical engineering, AI, machine learning, and other applications.
Interesting. Maybe tell us the title of your capstone project, and maybe in simplest terms, what's the project about?
My project title is Smart Alarm System of Last Resort. And in simple terms, I'll describe this project. The project is basically about an alarm system which, upon the failure of the conventional alarm systems, involving the water sprinklers, the audio alarms in buildings, when they fail in the event of fire, now our alarm system kicks in. Its role is to automatically alert any nearby fire station for prompt action. This project is inspired out of human error and delays in emergency response characteristic in third world countries, East Africa, and Africa at large.
Thank you for getting us to your inspiration because that was my next question. Walk us through how the project works, like you're explaining it to a high school student.
In simple terms, my project detects fire in its early stages and promptly calls the nearby fire department and also other third parties, e.g. the owner of the building, the manager of the business premise in fire.
And what were the main steps or stages in your process?
The main processes in my project involve three things. Three things. One, detection. The second one is communication, and the third one is alert. Those were the main processes.
Through this project, I know you used maybe specific tools or softwares. Maybe you can tell us some of these equipments.
The main module is at the top of that building, far from any scenario that might endanger it in terms of fire. And the receiver module is at the fire station.
Interesting. So I know through these modules and steps, you use specific tools, maybe softwares. Maybe you can tell us some of these equipments that you used.
Um, for the equipments, in my sub module, I used a temperature sensor, a carbon monoxide level sensor, a heat sensor, and a thermal camera. It works in this logic. The first thing we detect is carbon monoxide levels. I used MQ7 sensor.
Mm-hmm.
When it detects a high threshold of carbon, when the carbon detection exceeds the set threshold, it moves on to detect temperature. And in temperature, I used the DSB18 sensor. When now it checks whether temperature has exceeded, it moves to the next. Now it checks for flame. For the flame sensing, I use the KSY 026 KY026 sensor. When it detects the flame, now it moves to the final step. The final step being the thermal imaging. It captures the image and passes this image, PARSE, and passes this image. This image is relayed to the main module. Remember, this is the submodule. It is relayed to the main module via Bluetooth, using a an ESP32 sensor. When it reaches the main module, the only role of the main module is now to contact the fire department. The ESP32 in the main module has a GSM. A GSM is like a SIM card.
Are these things we know? GSM.
Yeah. Unaona when you open at the back of those old phones, there's that SIM card. You know the SIM card, right? Yeah, so that's basically a SIM card. Now GSM is like that SIM card is meant for the phone, and now the GSM is my SIM card meant to be used in another device for communication. So the GSM SIM 900,
Makes sense.
yeah, it now relays that information to via the mobile communication to the fire department and also to the owner of the building in a simple alert message. SOS, your building is in fire, and it relays the geolocation of this building as coded into this system. Now in the fire department, we have the receiver module. The receiver module also has an ESP32 and a GSM to receive this information. It receives the information, and a series of events sets off alarm at the fire station. The fire department receives the geolocation where this fire is occurring, and prompt action can be taken there afterwards.
Are there maybe any softwares that you used to run all day?
Yeah, the softwares. I used the Proteus software to design. I also used the KeyCard software to design the PCB. When you open your phone, any electronic, there's a certain green board. That's now a PCB.
Motherboard.
Yeah, the motherboard. I used KeyCard to develop the PCB, Proteus to test this system whether it's working, and now to set up the whole system, I used the Arduino kit, and also I bought the ESP32 sensor. Yes.
I understand that throughout this project, it wasn't something easy. Maybe you can tell us the biggest challenges you faced during this project.
A lot of challenges. We faced a lot of challenges. The first challenge was setting up a good team, because you cannot do this all alone. Was setting up a good team. In the first instant, I managed to get some guys who are good at what they do. I thought they were good, but we did not achieve our objective, since there was some laxity in some department, where not department entirely, some laxity in some area of assignment. The second challenge I faced was communications challenge. We did not have we were not sure whether GSM would actually work, since it's 2G we are using, and now your phone is using 5G, 4G communication. And given that there are many buildings around the CBD, these buildings and most of these buildings have transceivers, boosters, and also communication systems, we feared that our communication system might interfere with these channels of communications in the CBD. The last challenge we faced now was raising money to
You're just a student.
Yeah, we're just students. And how did we solve these challenges? I presume you'll ask that. The first challenge, I solved it by basically disbanding the group and trying to look for another group. The second challenge, we solved it by approaching professionals in telecommunications. Some of them were students who preceded us, who had graduated long before we even came to campus. And the third problem, we solved it by signing into hackathons. And in these hackathons, there are prize money to be won. So we use this prize money to raise up the funds, also asking for friends and family to fund the project. Yeah.
Okay. Now let's get into the real world relevance. Maybe you can tell us, how does your project solve a real life problem, or how does it improve existing solutions?
In solving real world problems, we focused on a need or an area that we realized in the third world country that we live in. Emergency response often comes late. When there is fire, the brigades often come when the fire has already engulfed a major destroyed a large part of the premise. So based on the late emergency response, we devised a solution to factor in for this lateness. These late responses are often caused by human errors. For example, reluctance to promptly contact these services, or they might contact these services, but when it's too late. See? And for the existing solutions, we know that buildings have fire alarms. We know that major towers in Nairobi have fire alarms. But upon asking and doing some inquiry to the fire department, we realized that none of these fire alarms alert the fire department promptly, surprisingly enough.
Okay. And who do you think would benefit maybe from most of this innovation?
Before I answer this, when you are innovating something, people often advise you to innovate something that reaches even the common mwananchi, as they would say. But this is a highly powered system which might not be bought by the common mwananchi. But for gated communities, it might be bought. We focused majorly on gated communities and also on industries. On industry, we believe that when industries are destroyed and jobs are at stake out of losses and imminent layouts, us implementing this simple project to this massive industry would in turn have a higher return on investment on their side, and it will save a lot of money and a lot of jobs indirectly. And for the gated communities, we saw that this project can be mostly applicable to gated communities, as we also advocate for smart living and as we advance as Africa to meet the standards of the Europeans, the Asians, and also the Americas in our house units.
Yeah, maybe you can tell us, okay, knowing that this is an innovation, that it's your first thing doing, maybe you can tell us one thing that was surprising to do or learn while working on this innovation.
The first thing was how limited time we have to pursue anything, how time is limited. I remember there was a time when we were trying to configure some code to combine codes, to combine the carbon sensing, the temperature sensing, the flame sensing, the communication to the main module, the communication to the receiver module. We realized that it takes a lot of time. We thought that you do simple things just by printing ama inputting your needs to an AI platform, but AI did maybe 20% and 80% will be from us. Another thing that I realized was how far behind we are as Kenya, and oftenly how we overlook some certain simple solutions to big problems, e.g. the unavailability of alarm systems to communicate with the fire departments.
So interesting thing with the project, that it has a future. And maybe you can tell us, looking back, what was the most proud thing in your project?
Getting rid of the fear that I must be plagiarizing someone else's work. I had conceived the project for many months, but I had a premonition that maybe someone else has done it in India, maybe someone else has done it in USA. But upon doing the literature review now, and upon going to the professionals, to the fire department agency and consulting, I realized that there is no project similar to this. So that moment, I'm proud of that moment. Yeah.
This must have been a catchy project to your supervisor. Maybe you can tell us what was his or hers, the feedback you got from them.
The feedback, at first, it was a laid back feedback. They were not really interested, but upon finishing the presentation, now I could see the eyes glowing up. It was an interesting project, and they loved it that I simplified a simple and a common problem, and I tried to solve it in the most efficient way possible.
Yeah, it actually is. Are you maybe planning on taking this project further, maybe as a business or publication, or even a postgraduate study,
As a business, we've approached several organizations, the fire department, Nairobi County, and we are planning to approach companies that deal with fire systems, and yeah, from then on, we know what we'll do. But yeah, we have to monetize this thing.
Okay, thank you, Lewis. And maybe before we end this, you can tell us an advice that you can give to maybe an upcoming student tackling as a capstone project.
And upcoming students, I will advise them to focus majorly on AI. We did not focus on AI since we are trying to solve a common old problem, but the world is developing fast and new problems are approaching. So I would advise them to jump on the boat and ride with AI. And the future is AI. Billions of dollars are being invested in the Saudis, the Qatari, and the Americas based on AI and machine learning. Yeah.
That was Lewis Minda helping us see STEM through fresh, clear lens. Thanks so much for joining us and sharing your journey.
Thank you for having me.